You ever look at a list of country codes and just wonder? It's not alphabetical. It's definitely not geographical. It just feels like this random jumble of numbers. Well, what if I told you that this map isn't random at all? It's a story. A story about old tech, modern politics, and some incredible compromises. And it all starts with one simple question.
Right? How did we end up with this? It's a system we all use every single day, probably without a second thought. But getting here was anything but simple. And to understand it, we've got to unravel a few key mysteries first.
Okay, so for example, why do the US and Canada get to share the top spot, +1? And why do the single-digit codes just jump from +1 all the way to +7? What happened to 2, 3, 4, 5, and 6? And maybe the weirdest one of all, how on earth did Greenland, sitting right there in North America, get a phone code that puts it in the African zone? And you got these major world powers, right, like the UK and France. Why did they get stuck with +44 and +33? These aren't mistakes. Every single one of them is a clue.
To find the answers, we have to rewind the clock. Way back. Back to a time before you could just tap a number and instantly talk to someone on the other side of the planet. We're heading into the age of operators.
So imagine this. You want to call someone overseas. You'd pick up the phone, and you'd get a local operator. You'd tell them who you want to call, and they would start physically plugging in wires, connecting you through a chain of other operators, sometimes across several countries, all through these huge copper cables. It was slow, it was expensive, and half the time you could barely hear the other person. It kind of worked, but the whole system was about to burst at the seams.
And the breaking point? That came in 1956, with the first transatlantic telephone cable. All of a sudden, international calling just exploded. The old manual system of human operators just couldn't keep up. The world desperately needed a new, automated way for people to dial direct. And so, in the early 1960s, the country code system was born out of this necessity.
Now, you have to remember the technology they were working with. The rotary phone. To dial a number, you had to stick your finger in a hole and pull that disc all the way around. And because of how it worked mechanically, dialing a 9 took way longer than dialing a 1. And this tiny little technical fact, that shorter, lower numbers were faster and easier to dial, is the hidden key to understanding this entire map.
So the problem was crystal clear. The world needed a single, automated, standardized system. But who could possibly get every single country on Earth to agree on a plan?
Well, that job fell to the International Telecommunication Union, or the ITU. It's a UN agency that had been dealing with this kind of thing since the telegraph days. They were handed this monumental task: create a phone number system for the entire planet.
And honestly, the system they came up with was brilliant. They basically split the world into 9 zones. Zone 1 was for North America, Zone 2 was for Africa. Europe was so crowded it got 2 zones, 3 and 4. Zone 5 was for South and Central America, and so on. This is the fundamental logic of the whole map. And it's why there's no country with just +2 or +3. Those numbers aren't for countries, they're for entire continents. Of course, having a neat plan on paper is one thing. The real world, well, that's another. The second you start assigning numbers to actual nations, geography starts to take a backseat to good old-fashioned politics and power.
Remember how shorter numbers were easier and faster to dial? Well, guess who got them? The most powerful and influential nations, of course. The US and Canada already had their own integrated system, so they got to keep the super desirable +1. The Soviet Union, because of its enormous size, got the only other single-digit code +7. And over in Europe, big players like France and the UK got what everyone considered to be the nicer, more memorable 2-digit codes, like +33 and +44.
So that brings us back to Greenland. This is the perfect example of how the rules got bent. Geographically, it's in North America, so it should be in Zone 1. But politically, it was tied to Denmark, over in Europe. The problem was, by the time it needed a code, Europe's zones were already full. So the ITU basically just went looking for an open slot. And where did they find one? Zone 2, Africa. So Greenland got +299. It was a purely practical decision that had absolutely nothing to do with geography. Sometimes deciding who gets a code means wading into really complicated politics. Take Taiwan, for instance. China considers it a province, but Taiwan operates as an independent nation with its own separate telecom network. The ITU couldn't pick a side, so what did they do? They came up with a very clever diplomatic solution. They gave the network a code,
plus 886, but in the official documents, they listed it as Taiwan, China, or sometimes just reserved, basically giving them a number without making a political statement on sovereignty.
It was a very similar story with Kosovo. After it declared independence from Serbia, for years it didn't have its own code. People there had to use numbers from Monaco or Slovenia, which was awkward. Finally, in 2016, the ITU threaded that needle again. They issued the code plus 383, but they did it by recognizing Kosovo as a distinct telecommunications network while staying completely neutral on whether it was a sovereign state. It's a subtle but really important distinction. And just as new codes are born out of politics, old ones can disappear. This map is like a living history book. The country code plus 37 for East Germany, gone. Plus 38 for Yugoslavia, doesn't exist anymore. Plus 42 for Czechoslovakia, same story. These are digital ghosts, artifacts of a world map that has been completely redrawn.
Okay, so all of this brings us to today. In a world of WhatsApp, Wi-Fi calling, and constant internet, you have to ask, do these 60-year-old codes, designed for rotary phones and copper wires, even matter anymore?
And it's a totally fair question. I mean, when you make a call over the internet, you're not really using that traditional phone network. Your voice is just being turned into data, just like an email or a photo. Technically, you don't need a phone number at all for that, let alone a country code. So you'd think their days would be numbered, right?
Well, here's the brilliant twist. Back in 1997, the ITU saw where things were going and made a huge conceptual shift. They basically decided that a phone number was no longer an address for a specific phone line or machine. Instead, it was a name, a universal, globally unique identifier for a person or a service. It became totally separate from the technology you use to connect.
So why are they still around? Well, for one, pure inertia. Ripping out a system this deeply woven into everything would be an absolute nightmare. But more importantly, we all just get them. Everybody knows how a phone number works. It's become the simple, reliable way to identify someone. It's basically the username for the real world, and that has a ton of value, even in the age of the internet. So the next time you dial a plus 44 or a plus 1, just take a second to think about what you're really looking at. It's not just a bunch of numbers. It's a map of history. It's a relic of old technology. And, as it turns out, it really is a testament to one of the most impressive political compromises ever made. It's a symbol of a connected world, and that's pretty amazing.